Hi everyone, thanks for watching this chemistry tutorial. In this tutorial, you will learn how to draw Lewis dot structure. And drawing Lewis dot structure is very important in terms of knowing the shape of the molecule. Now, in this tutorial, we are just focusing on the drawing of the Lewis dot structure. Now, in the process of drawing this structure, we will have some rules to follow. I would talk about it in the tutorial, and I will put the captions on it, so make sure you look at the captions. Now, we will use these two examples first to show you the rules of the drawing the Lewis dot structure. We will go over some more examples after we finish these two. Okay, so now let's start with Ch4 methane. Okay, so now for Ch4, so we see the chemical formula. So where do we get started? So the first thing that we get started is to count the number of valence electrons. Okay, in this molecule. So we look at the carbon, we look at the hydrogen to see how many valence electrons total in the valence shell. Okay, so now where do we get the valence electrons? Well, you have your periodic table. That's a very useful tool. On the periodic table, I hope you knew that. I hope you knew this by now, that the group numbers are actually giving you a very good hint on the valence, the number of valence electrons. Now, for carbon, it is in group 14, so there are 4 valence electrons. So it will be the group number minus the 10. The reason why we minus 10 is because we have the 10 columns, 10 groups in the transition metal, the D block. So if we take those out, that will be the number of valence electrons in the outermost shell. So we have 4 electrons from carbon, okay? And we have hydrogen right here. Hydrogen is in group 1, so it has 1 valence electron, okay? And we have 4 hydrogens total, so we have 4 times 1 valence electrons. So if you do the math, the total valence electrons in this molecule is going to be 8 electrons. Alright, so now we have 8 valence electrons. We're going to draw the Lewis dot structure with 8 electrons. Now what I want you to be aware is that while you do the Lewis dot structure, I would like you to keep track of the number of electrons that has yet to be drawn. Okay, this is a very critical step. Now, so after we finish calculating the number of valence electrons, what we will do is to connect the atoms together, because it is a molecule, so they would connect together by covalent bonds. So we would draw this, okay, and we're going to connect the atoms with a single line. Okay, so we have 4 lines between the hydrogens and the carbon. Now, our students would ask, how do you know, or how do we know, what is which one is the central atom? Okay, is it a hydrogen or is it a carbon? Now, frankly speaking, it has to do with the experience. But the other way to think about this is to think about the number of bonds that an atom, okay, could make. Now, if we look at carbon and hydrogen, this is a very good example to show you that carbon has to be the central atom. The reason for that is, well, if you look at hydrogen, okay, hydrogen is group 1, is in the first period, okay, it has only 1 energy level. Now, the maximum number of electrons for hydrogen that could take, it's going to be only 2 electrons. The reason for this is in the first shell, which is the valence shell for hydrogen, well, there can only be 2 electrons, because we only have one s2, or the one s orbital in the hydrogen. All right. So if we look at these bonds, each bond represents 2 electrons. That means each line right here represents 2 electrons. Let's count how many bonds we have here. 1, 2, 3, and 4. If each bond has 2 electrons and we have 4 bonds right here, that means we have drawn all the 8 electrons. So we have 0 electrons remaining. Well, that doesn't mean we have a problem. Okay, it's just showing you that how many electrons that we have left. Now, the next step is Well, the reason why we have molecules, the reason why atoms are coming together, sharing electrons, is because by combining together, by sharing electrons together, they will be more stable. So now, let's see if they're stable. How do we know? We just check if each one is octet. Octet means 8 electrons in the valence shell. Now, there are a few exceptions to this octet rule. Now, for hydrogen and helium, although we don't see helium being in the compound, so mostly we will see hydrogen. For hydrogen, we will have 2 electrons for the maximum, just like this, because of the limitation of the first energy level. Now, there are a few more exceptions. The other exceptions are, for boron, boron will only need 6 electrons total in the valence shell. Beryllium would only need 4 electrons in the valence shell. Now, what is even more interesting is that for any elements that is in the 3rd period and beyond, or below, okay, they are capable of having more than 8 electrons when they form a molecule. Now, let me be clear on this one. When I say that they can have more than 8 electrons, it does not mean that they have to be over 8 electrons all the time. They could still have 8 electrons. So in this case, it depends on the molecular structure. But in this case, we are going to focus on the simpler models. Okay? So here we have carbon in the 2nd period. So it will be just the regular octet rule. Make sure it has 8 electrons. So now let's check every single atom. For each of the hydrogen right here, they have the covalent bond. That means they have the 2 electrons for each of the hydrogen. That means they are all octet. Now let's move on. Look at carbon. Carbon, it has 4 covalent bonds around itself. Each bond has 2 electrons. That means it has 8 total electrons. So carbon is octet as well. So at this stage, if every single atom is octet, and you have drawn all the electrons, that this structure is your Lewis dot structure. Okay? Now this is a very simple example, and we will go to the more complicated example as we move on. Now let's look at the Ch4 right here. So we're going to do the same procedure. We're going to calculate the number of valence electrons. Okay, so let me erase the number right here. So the calculation here is for Ch4. Now for carbon, we have 4 electrons. Okay, and for fluorine, we have 4 fluorines here, and each fluorine has 7 valence electrons. How do we know that? If you look at fluorine, it is in group 17. So if we take 17 minus 10, then we have 7 valence electrons. So we have 4 of the fluorine, and each fluorine atom has 7 valence electrons. Now we do the math. 4 electrons plus 28 electrons will give you a total of 32 electrons. So in this case, okay, we have 32 electrons to draw. All right, now let's get started. So we will do the same thing. All right, we draw the atoms, and in this case, carbon will be the central atom. The reason for that is fluorine is usually making 1 bond only because it needs 1 electron to become octet. So all it needs to do is to share only 1 electron with another atom. So usually we only see, we only see fluorine making 1 bond. Okay, so we would connect the fluorine with the carbon like this. And the next thing we would do is, keep track of the electrons. We have drawn 8 electrons, so let's subtract 8 right here. All right, some accounting right here. So we do the math. 32 minus 8, we got 24 electrons remaining to be drawn. So what do we do with these 24 electrons? Well, remember that when atoms come together, they will like to become octet so that they become stable. So let's make them stable. The way we do this is to distribute these 24 electrons onto the fluorine atoms, one by one. It doesn't matter which one you start. So let's do it one by one. 1, 2, 3, 4, 5, 6. Okay, we've drawn 6. 7, 8, 9, 10, 11, 12. Okay, keep going. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so now we have drawn all 24 electrons, and every single fluorine is octet. Okay, the reason why we only draw 6 dots, okay, 6 electrons for each fluorine is because we only need 8 electrons for each fluorine. It has 2 electrons from the covalent bond, so you need 6 electrons on the outside to become octet. Alright, now, we have drawn all the electrons. Let's make sure. And what's next? Well, we check the atoms if they are octet. We just confirm that the fluorine is octet. So now we look at the carbon. Carbon has 4 covalent bonds, so it is octet because there are a total of 8 electrons right here. So this would be the Lewis dot structure for CF4. Now let's consider another example. Something that's quite common. We hear this molecule all the time. This is CO2. Okay, carbon dioxide. All right, now for carbon dioxide we use the same thing. You can do it along the way. You can do it on paper. So let's do the valence electrons count. Okay, so by now I hope you understand how we get the valence electrons. Okay, so let's do the math. 4 plus 12. So we have a total of 16 electrons. Okay, so now we have a total of 16 electrons to draw. And let's draw the atoms out and connect them together with a single bond. Now, we have drawn 2 single bonds. We will subtract 4 electrons from the total valence electrons. So there we have 12 electrons remaining. Now, what's next? Okay, we follow the same route. We will distribute these 12 electrons to the outside atom. Okay. Now, there's it may happen to you or to other students that you may want to think we distribute evenly to the oxygen since they are both outside atoms. Well, what I would suggest you do, and this is the good way to do, is to focus one atom at a time. Things will work out by itself at the end. 12 electrons, make sure that we fill up the outside atom to become octet. Oxygen, it has 2 electrons right now. 1, 2, 3, 4, 5, 6, 7, 8. We have drawn 6 electrons, and now the oxygen has a total of 8 electrons. 6 electrons that we just drew, and 2 electrons from the covalent bond. It is octet. We have drawn 6, so we have 6 remaining. 1, 2, 3, 4, 5, 6. We draw the remaining 6 on the other outside atom, the oxygen, and now it is octet for oxygen. Now, we are not done yet because we have to make sure, we have to check and make sure every single atom is octet. Now, oxygens, they are octet, we just confirmed it. What about carbon? Carbon is not octet yet because if you count it, we have 1, 2, 3, 4, just 4 electrons. Well, we're not going to leave carbon like this, not being octet, so we have to make sure that it has 8 electrons. But how do we make sure that it has 8 electrons while we have drawn 12 electrons and 0 electrons is remaining? We don't have any more electrons to draw, and how do we make carbon octet? Well, what we can do is to have the oxygen share more electrons. So what we do is to put 2 electrons into here. Okay? So we put one, let me just show you one more time. Okay? We had 2 dots right here. So what we do is to put these, to put this pair of electrons to make the second bond, which is the double bond. Okay? So when we do this, make sure you erase the 2 electrons because now the 2 electrons is in the double bond. Okay? Now the good thing about sharing these electrons, the unpaired the lone pair electrons. Okay, the lone pair electrons sharing between oxygen and carbon is that when we do this, the electron count for oxygen remains the same, but for carbon, it is going to be higher. Now it has 1, 2, 3, 4, 5, 6. 6 total of electrons. Now it still needs 2 more. Okay, where would it get 2 more electrons? Well, gotta think about this. Are we going to take 2 electrons from this oxygen and put in here to make a triple bond, or are we going to take 2 electrons from this oxygen to make another double bond? Okay, it's a good, very good question to think about here. Now, technically speaking, if we just focus on drawing the Lewis dot structure, it doesn't really matter.